Okay, welcome back. Let's talk about the next concept here, constant variables. Well, what is a constant variable? Well, it's really what the name suggests. It's a variable that is read-only. It's constant. You can read it, but you cannot write to it. It's constant. The value will never change once it's initialized. And this follows a kind of a guiding principle related to programming that if the programmer should not be able to access some piece of information, then they should not be allowed to access this. What you're really trying to do here is you're trying to prevent people from making silly mistakes or breaking something accidentally. Real systems are complicated. Real systems have lots of variables, lots of different programming files, teams of people working on building some sort of complicated piece of software, and it's easy to make mistakes. So what we want to do is we want to prevent people from making mistakes. If there's a piece of information that clearly should only be able to be read and not written to, then make it that way. Restrict access. And this happens from basic security perspective all the time, that you want to allow, like, say, the least amount of access to personnel to a certain restricted area as necessary to get the job done. It's kind of a similar security process where you're minimizing risk and you're minimizing the ability of people for accidentally doing something, or potentially even on purpose. So let's give an example here. And this is a pretty simple concept, but I want to also highlight some conventions here at the same time. So this is a piece of software here that calculates the distance a lightning strike is from your present position based on the time it took from when you're seeing the lightning strike to hearing the thunder. So the math here takes into account a couple constant piece of information, some like basically natural constants, which is the speed of sound at sea level in miles per hour. All right, so 761.2 miles per hour, speed of sound at sea level. Now that value, think about it, doesn't change, right? That is what it is. It's a property of nature. It's just a fixed value. And when we add this const here before the data type declaration, const, const for constant, that makes it so that that value, that variable is read only, okay? You will actually get a compile error if you try to write to that variable, okay? Same with the second variable here, seconds per hour, right? That is also constant, right? If you try to change that, you're making a mistake, right? You're violating what that variable is supposed to store. It's not really a variable in the sense. This variable kind of indicates that the value can vary, right? It's fixed, it's constant, it's a piece of information stored in memory that cannot be altered. Okay. Then we have get some information for the user, calculate it, and we're going to calculate the distance approximately that the lightning strike is from a given person. So here it is. I've got it in my IDE here. You can see that there's a couple things I want to point out. Now, a standard, right? Standards are a really important aspect of engineering. They allow us to basically, to have a constant framework for being able to build things and interface things. And there are also a lot of kind of popular standards or conventions for programmers to follow to make sure that we're writing things that other people that you're working with can understand and make sense of easily. So one of these is that for constant variables, a convention is to make them all capital letters. Okay, the reason now, the compiler will let you if you don't do that, right? It's not like it's going to break. However, the reason that's a very popular convention to follow is all capitals is you could look down here at another piece of the code and you could tell just by looking at the variable that that these are read only, right? It just kind of helps make things a little easier as you could just look at the variable name and know it's a constant without having to look somewhere else in the code. Okay. Now I can compile and run this. Let's kind of see this piece of software in action. Right, it's going to prompt me here to say, hey, well, what's the seconds between the lightning and the thunder? Let's say maybe it's 3.5 seconds, and it says, okay, that's about 3/4 of a mile away, approximately. Okay, so that works no problem. Okay, now what I want to illustrate here is I'm going to break this on purpose to try to just show you what happens when you're not using constant variables correctly. Let's imagine that I tried to, for some reason, I made a mistake. And I'm like, oh, I'm going to change the speed of sound to something else, right? Maybe we could do the math and we think that it's supposed to be in something different, like kilometers per hour or whatever. So I'm just going to put a value in here. Let's imagine that I thought it was going to be 1200. Okay. And since it's a double, I'll illustrate that. It was 1200 exactly. Okay. And what's going to happen here is I go to compile this. I'm actually going to get a compile error. Okay, we can see it. The IDE is indicating that. Let's actually look at that error and read it. Now, I will try to emphasize here that I've always been surprised. It comes from experience, but when you're learning how to program, don't be like so scared of errors, right? Errors can be your friend, especially compile errors. They're telling you something's wrong and they're helping you fix it. Right. So when you get an error, don't just like give up and say, oh my God, it's not working. Right. That's part of the process. You're always going to get these errors. You got to work through them. And you get quicker about interpreting them and fixing them over time. This is some error messages are better than others. This is a pretty good, clear error message. It says error assignment of read-only variable, right? Assignment of read-only variable. Basically saying, hey, you're writing to a read-only variable. You can only read from it. You cannot write to it. Okay. And we want that, right? A lot of the compile errors could doing you a favor. They're telling you something's wrong, and they're trying to give you an opportunity to fix it. And it's a lot easier to fix errors at compile time than subtle bugs that happen when you're actually trying to debug the logic of a program. Okay, so for instance, this is the compile is telling you that, hey, this is a clear mistake. You're not supposed to change this. Okay. So that's one way that constant variables are preventing you from changing things that you shouldn't be allowed to change. Okay. All right. So that's it for the video. I told you it was going to be short. We're going to leave it at that. Just keep in mind, just one thing left to reiterate is, I just want to mention that, once again, that these programming conventions are important, right? Having code readable is going to help you. It's going to help other people. It's going to get you in good habits. And one of the ones I'd like you to remember, right, is that constant variables should be all uppercase, okay? But there's others too in terms of properly indenting your code, properly commenting your code, right? Ways in which you're styling the code to be clear, readable, understandable, right? It's going to help you debug. It's going to get you in good habits. All right, so we'll follow up more on that at another time.